Okay, hello everyone, welcome to another video. We got better mic audio. I have this big ass mic. I did buy a little mic, but audio, the wire wasn't long enough and just getting it all hooked up took too long, so I'm just using my big mic. The audio will be a lot better this episode or this video. What are we doing today? Today we are going over electrolysis. This is for AQA and Edexcel. It's a required practical. It's fairly simple once you learn it. It's not very hard to remember, but there are a lot of rules in it, and as with everything, when there's lots of rules, it's very easy to forget certain rules. But just stick this to your memory. Tomorrow is our chemistry exam, and I wish you all luck, as well as the geography exam. So good luck with your exams. Make sure you revise. Okay, with electrolysis. So as a required practical, you do have to remember certain things. There are certain things I haven't written on the board, which I want you to remember by yourself. But let's start. Well, what is electrolysis? Electrolysis is breaking things down using electricity. In this case, we're breaking down ions, so ionic compounds. So if we take an example of salt water, this is the ionic compound of sodium and chlorine, a halogen, and a alkali metal. Yes, there we go. My memory's jogged. So that's those two together. How does electrolysis happen? Well, it's a fairly simple, as I said. What you have is you have the solution inside a beaker, and you have two terminals. The terminals are, named anode and cathode. The best way to remember them is one stands for the positive and one stands for the negative, and use the acronym PANIC. Positive is anode and negative is cathode. It's fairly simple to remember. Just remember PANIC when you're panicking. And what you're going to have is you're going to have a molten or an aqueous solution of whatever compound you're trying to break down. So in this case, we're going to use salt water as it's a really easy example, but we're going to have an aqueous solution, which just means dissolved in water. So we're going to have a dissolved in water, salt water basically, or you can have it molten where you melt it all the way down and it'll be a liquid molten. There's a fly in my room. There's a liquid molten substance. It's fairly simple. When you have molten, it's just the positive. We'll go through this. At each terminal, one is positive and one is negative. You will have at the negative terminals, the opposite attracts. Always just remember two sides of a magnet. The positive ion will go there, which in this case, as you can see through this half equation, it is sodium. Sodium is positive, and the chlorine will go to the positive terminal as it's negative. That's how that works. But it changes a bit when we have an aqueous solution. That's where people tend to fuck up, is at the aqueous solution, because it's easy, but you can forget it quite easily. This is where all the ruling comes in, and this is where it gets a tiny bit complex. So we're going to be looking at the reactivity series. This is going to become more and more important as you look through this experiment. I do suggest remembering certain parts of the reactivity series. I have a complex way of remembering it, but really for this experiment, you only need to remember the hydrogen and below. And you just need to know that everything above hydrogen follows a specific type of rule. But if you want to remember below hydrogen, just remember the 4 types of badges that you'll get on sports day, or when you win a medal. You'll have copper, which you can just swap out for bronze, but it is copper. So copper, then you'll have your silver, which is 2, and then you have your gold, which is first place. But then sometimes you might even have platinum, or you could think of rarity and the prices. Platinum is more expensive than gold. Gold is more expensive than silver. Silver is more expensive than copper. You can do it that way. What else? Well, then we have all these lovely things. And this part here, remember the top part of the reactivity series is simply group 1 and a few of group 2. So that's calcium and magnesium specifically. If you look at the top 3, you have potassium, sodium, and lithium in order of reactivity on group 1. So if you can remember your alkalis, if you have a periodic table, I've said this, you can easily get a grade 6 if you have a periodic table in the chemistry exam, because a lot of it is just using the periodic table. Now, how does electrolysis work? Well, when you have a current running through a molten or aqueous solution, such as the salt water, what will happen is we all know that when you don't mix water and electricity together, well, technically, yes, but you don't mix salt water and electricity together. The reason why is because the ions will then separate and they will carry electricity from one terminal to the other, allowing for a flow of electricity and a voltage to pass through it, or a current to pass through it. And in this case, we can use that to produce certain things. So let's go over the first rules. First, we have the most important rule to remember is if a halogen is present, you're going to have it form at the positive terminal, at the anode. Now, the reason for this is the halogens are the most reactive, so you won't get other things like hydrogen forming or oxygen, but what you will have is the halogens forming at the positive terminal. So in this case, in the salt case, the Na will become Na positive and the chlorine will become chlorine negative. The chlorine will then go to the positive terminal as it is present, and you will not get any oxygen forming there. Now, the next rule you need to know is, this is where the reactivity series comes into play, is if it is below hydrogen in reactivity, it will form at the negative terminal. It's a bit weird, but that is how it works. And if it's above, hydrogen will form at the negative terminal. So if we look at salt water, if you can see from my dodgy ass drawing, there is two sets of bubbles forming. The second set of bubbles the bubbles by the positive is obviously chlorine, because chlorine is present, it's a halogen, and halogens are group 7s if you do not know that. If you don't know that and you're going into your exam, please go over the periodic table. It's one of the most important things. I'm very steadfast on it. If you remember your periodic table properly and you really learn why it works the way it works and whatnot, chemistry is a piss easy subject. In this case, our group 7 element is present, so it will form at the positive. And for the negative, we have a group 1 metal, which is our alkali metals, and it is more reactive than hydrogen, so we'll have hydrogen forming at the negative terminal. Now, it changes, obviously, when you have something less reactive than hydrogen. So I've given the example of copper chloride. They can use any type of bond or any type of solution, and you just need to remember that, less reactive than hydrogen goes to negative, more reactive than hydrogen goes to the negative. In this example, we use copper chloride. Copper is less reactive than hydrogen, just about, and it will form copper on the edges of the terminal. You'll see literal substances forming on the edge. It may point at it and say, what is this in the solution? If it's a copper chloride solution, you'll say copper. If it's a, silver fluorine solution, then, you'll say silver and whatnot. Now, the other ruling you have to remember is that what if we do have, in the NaCl solution, what happens to the sodium? Well, the sodium is not just going to float about and settle to the bottom unless it's molten. If it's a molten solution, there's nothing for it to react with, so it will just go to the bottom. But we have an aqueous solution, and there's other things in the water, such as water. So what is water? Water is H2O, and it breaks into its own ions. It breaks into a H positive ion, which is that hydrogen that's forming at these terminals. It comes from the water, and it also breaks down into a hydroxide. So a hydroxide is simply oxygen and hydrogen bonded together, which forms a negative ion. That is, as oxygen is 2- and hydrogen is 1+. So in this whole formula, you only have one of the electrons on the oxygen being filled in, and there's another electron that's needed, which is being supplied by the electricity, and therefore this is a negative ion. This will then settle, and it will react with the sodium to make a sodium hydroxide. So when you have something that is, if a halogen is present and you have something more reactive than hydrogen also present, what you will have is you'll have a metal hydroxide forming alongside it. Now, this will be standard for everything. So if we swap out NaCl with KCl, so potassium chloride, you will also have a potassium hydroxide forming. It's a pretty simple rule. It's just what's left in the water will react with what's being produced. Now, what about in the case of the copper chloride? Well, both the chlorine and the copper is being released outwards, so there's not really anything left to react with. You won't get any one second, my piece is just off. You won't get no reactions. You won't get nothing really forming beyond that. What else do we need to go over? Well, when we do have these gases forming, especially in this case where we have, a halogen or we have oxygen forming, that's another rule I need to go over, but it will form something called a diatomic atom. The reason for this is because these elements specifically, so it's oxygen, nitrogen, and the group 7 elements and hydrogen are all diatomic elements. They will form double bonds with themselves. So if we look at this oxygen that I've given an example of, you can see they're sharing, this is covalent bonding because it's between two non-metals. You can see they're sharing 4 electrons here, which completes each other's electron ring, their final ring, but it's a very weak bonding, so these will break to react with other things, which is more stable. And this is, if I gonna give you a quick tip, don't include this in the exam if they ask about it. I mean, you can. This is more A-level / university, but the reason why is because the electrons and the atom likes to be in the least charged position and the most stable position it can be. It's why we have things such as explosives. Explosives will have really kind of, the best way to explain it is unstable bonds. So a lot of explosives like TNT, trinitrotoluene, has those nitro groups on them. Those are NO2 groups. They're very unstable. They like to break off and, form their own diatomic nitrogen elements or compounds, if you want to say. But that's what kind of happens. We're same with trinitrocellulose. That's another nitro group on there. I tend to see explosives have a lot of nitrogen stuck on them because nitrogen likes to be on itself. It's not a group 8, but it tends to just want to bond with itself. That's my observation. Don't quote me on that. But basically, they would like to become more stable, so they'll break these bonds to react with anything else. That's just a little side note. This is not including electrolysis. This is just a bit of a chemistry note. So yeah, we'll form a Cl2. So when we're writing something, which you're going to have to learn to write is half equations, you have to account for that. So I've accounted for it if you see this. Now, when you do make half equations, they do say you can do takeaway. So you can have 2Cl minus take away 2E minus, which makes Cl2. But I prefer to add because that's what I was taught by my teacher. And it's kind of just like a force of habit because I've practiced it so much in this form that, it's just easier for me to write it like this. What is a half equation? You're simply showing what's happening with electrons. In this case, we have the sodium and the electron here joining to make just a stable sodium, no charge. The Na plus and the E minus. I've written it here. E stands for electron. That's pretty simple. Just practice half equations. I'd suggest watching a little video on them just after this. Just know you have to learn them and just do loads of practice. Just search 50 half equation questions and practice them, and it'll stick with you. That's what I did. It was boring as fuck, but you know what? It's the best way to learn is just repetition and practice. What else? The diatomic comes in case with the chlorine because obviously chlorine will always form a diatomic compound. So you'll always have Cl2, not just Cl, and you have to account for that with extra extra electron because obviously chlorine is a -1 charge, so you need 1 electron per chlorine. And you don't write Cl2 minus. What you write is 2Cl minus. I don't know why. It's kind of just something I was taught. It's a rule I just follow. Whether that's a rule you have to follow, I'm not sure, but for safety of mind, do it, or watch a video and do a bit of background research. What else do we need to go over? Yes, okay, we're going to go over the uses of... Oh, one last thing. We got to go over oxygen. What happens when you have no halogen present and you don't really have anything that's going to form at the positive ion? Well, what you'll have is oxygen will form. So this OH group will break down into oxygen 2 minus, and the oxygen will then react at the positive terminal, forming a O2 gas, which will then react with the carbon inside the terminal. The terminals are made out of graphite or graphene, and the carbon will react with the oxygens to form CO2, carbon dioxide, the thing that's slowly killing our world. But beyond that, that's what you just need to know about oxygen, is if oxygen is formed, it will react with the terminals. And it may ask a question like, why do the terminals need to be replaced? This will be a 2 marker, and you simply have to say oxygen is given off, the oxygen reacts with the carbon to form carbon dioxide, slowly eating away at the terminals. Beyond that, what is electrolysis used on? It's, if we look at the reactivity series, to get any of these metals, they will form as ores beyond these 3. These come as their pure elements, but these will come as ores. Copper comes as bauxite, I think, and a few other, iron comes in an iron oxide, whatnot. And we need to separate them because we want the elemental stuff. We want the good. You feel me? We want the pure shit, like a Mexican in a drug hotel. Anyways, that's shocking. For these elements, if they do come in a ore, we can use hydrogen to react them off because hydrogen is more reactive. We'll have something called a displacement reaction where it literally replaces it in the element or in the compound, and it will kick that element kind of out. So think of like, you know, that girl you like moving on from you and getting with another guy because he was more competitive with her, and you know. Anyways, with these ones, they're more reactive than hydrogen, so you can't use hydrogen, you have to use carbon to react them off. The best way to remember this, the way I remember it, is in Minecraft, you have to use a furnace, and you have to put coal with iron, or you put wood with iron, and you'll get iron from the iron, or you'll get iron. The reason why is because you're having a displacement reaction. The carbon in the coal and in the wood is burning, reacting with the iron oxide, replacing the iron in that compound, forming carbon dioxide and iron by itself. Iron will rust over time, so it will react with oxygen. So, you know, that's why we have steel and whatnot. And then we have these lovely groups here. These are more reactive than carbon, so how do you react them out? If they're the most reactive, how do you get them in the purest form? Well, we use electrolysis. We use electrolysis to get these out of their ore form. Another way electrolysis is used, it's used to form bleach. We make bleach on I think this is how they make it in thingy, but you can make bleach like this, where another rule of electrolysis is you never have these the two terminals touch, because electricity won't flow through the water or through the solution, rather it will just pass between the terminals. So what you really want to do is you want to have the two terminals as close together but not touching, and you put a salt water NaCl, specifically NaCl water solution, so a NaCl aqueous solution, and you'll run electricity through it, and as the terminals are close together, the chlorine will react with the sodium hydroxide to form bleach. Bleach is really easy to make. You can make it yourself if you wanted to, just be a bit careful, you know, electricity and whatnot. I'm not liable for any mistakes. You just need a beaker. You can get any bog standard beaker. I have one. I have a little beaker here. You could, if I fill this with salt water and then put 2 electrodes in there and run electricity, eventually it'll begin to form bleach. If you want to do this, I suggest not using just table salt or Himalayan salt. Use salt water from the ocean. The reason why is because your normal table salt will have caking agents in them, which may affect the reaction. So you kind of want the purest salts. Think of Jekyll and Hyde. But yeah, that's everything for electrolysis. I'm going to make a few more videos about a few more required practical. This is required, so learn this. Watch a few more videos. Don't only rely on my videos. You know, I'll give a brief explanation so you have a general understanding. But beyond that, I hope you guys enjoy it. Keep the revision up. Good luck, everyone. And yeah, I'll see you guys in the next video. Bye-bye.